Hello viewers, welcome to my channel Shraddha's Physics. This video is based on statistical mechanics for the core 14. Today we will see the negative temperature, whether it is possible or not possible. So according to the law of thermodynamics, there cannot be any temperature less than 0 Kelvin. So it means that a negative temperature is not possible on the Kelvin scale. Suppose all the negative temperature exist and it is attainable. So in that case, suppose the sink of the heat engine, it is at some negative temperature T2, that is equal to minus T2. So let us consider that this sink is in the temperature minus T2. So if you will calculate the efficiency, then efficiency eta will be 1 minus T2 by T1, where T2 is minus T2. So this minus minus becomes plus and the efficiency will be 1 plus T2 by T1. So here you can see that this efficiency is greater than 1. Clear? So since this is 1 plus T2 by T1, some addition of this term, so it will be definitely efficiency will be greater than 1. So it means that the efficiency of the energy greater than 1 is not possible because it is against the second law of thermodynamics. This cannot be greater than 1. So this is according to the law of thermodynamics. Now consider this 1 by T equal to dou S by dou E at constant V and N. So this 1 by T equal to 1 by epsilon dou S by dou N. Since E equal to total energy equal to N into epsilon, that is N is N1 minus N2. So we can write this simply as 1 by epsilon taken outside dou S by dou N. So from the previous we have calculated that this log omega will be equal to minus N1 log E N1 by N plus N2 log E N2 by N. So the in the two energy level system we have already studied that this log omega equal to the value of log omega equal to this much. So the entropy S equal to K log omega. So in place of log omega we have simply substituted this. Now you can see that this total number of particle n equal to n1 plus n2 and small n equal to n1 minus n2. And if we will add this n plus n, this will becomes n to n2 get cancelled, that will becomes 2n1 or n1 equal to 1 by 2 n plus n. Similarly you can calculate. So this n2 equal to n minus n1. In place of if we will put n1 value, then we will get n2 equal to half n minus n. So it has been already calculated in the previous video. So we have already calculated this n1 and n2. So putting this in equation 1, equation 1 means here 1 by T equal to 1 by epsilon del S by del N. So we will get 1 by T equal to minus Kb by epsilon dou by dou N of this will be half n plus n. This is n1 value log base E 1 by 2 n plus n by n plus 1 by 2 n minus n. This is n2 value log E 1 by 2 n minus n by n. So how this comes? So here you can see that 1 by T equal to 1 by epsilon dou S by dou N. So in place of S we have simply substituted n1 log E n1 by n plus n2 log E n2 by n. So in place of n1 we have just substituted this half n plus n. This dou by dou n is here. So in place of n1 we have just substituted this, and here in place of n1 here we have substituted, and in place of n2 we have substituted half n minus n. Clear? So now this 1 by 2 equal to minus Kb divided by epsilon. This will be 1 by 2 log n plus n divided by 2n. So the first term, because of here you can see that with respect to, if we will take the derivative with respect to n, this will become simply 1 by 2 and the rest of the term. So the first term is like 1 by 2 log of this much plus again this is 1 by 2 n plus n into this log of this much means 1 by half n plus n divided by n. So here you can see that this is 1 by 2 n plus n divided by 1 by 2 n plus n divided by n. So into this is where here you can see that this is 1 by 2 n plus n divided by n. So simply here you can write 1 by 2 n. Clear? So here this is 1 by 2n. Similarly, this will becomes minus half log e. By taking this derivative, this will be minus half log e means this will be half n minus n means taking the derivative with respect to small n, this will be minus 1 by 2, again log of this much, and the second term will be, this is your first term, minus half log e n minus n by 2n, and the second term will be, this is u into v, so this will be 1 by 2 n minus n divided by the derivative of log is 1 by this much, so 1 by 2 n minus n divided by this half n minus n divided by n into the derivative of this much will be minus 1 by 2n. So here you can see this. So now becomes minus kb by epsilon. This will be half log e n plus n minus half log e 2n. This will divided by, so this will becomes minus this much plus this will be, this will get cancelled. The remaining term will be 1 by 2n. This will becomes this term half n plus n get cancelled, and again 1 by n get cancelled. The remaining term is 1 by 2, again minus half log e n minus n by 2n. So this is minus half log e n minus n, minus minus becomes plus half log e, this is your 2n. Again this will be half n minus n get cancelled, this n get cancelled, this will be minus 1 divided by 2, this is minus 1 by 2. So 1 by 2 minus 1 by 2 get cancelled, half log e 2n minus half log e 2n, they will get cancelled. The remaining term is minus kb by epsilon half log n plus n minus half log e n minus n. So this will be taking 1 by 2 common and negative sign common, this will becomes log e n minus n divided by n plus n, or you can write in place of n minus n, this is your twice of n2, and in place of n plus n, this is twice of n1. So 2 get cancelled, this will becomes n2 by n1. So taking the reciprocal of this, or if we will write log e n1 by n2, so here we have just have to multiply minus 1 by 2, so that kb by 2e into 2 epsilon log base e n1 by n2. So at the absolute zero temperature, all the particles are in the lower energy state, that is suppose minus epsilon. So at the absolute zero temperature, so in that case the total number of particles will lie in the lower energy state, that is this much. So this n equal to n1 minus n2. So if we will put in place of n2, that is n, the total number of particles is in the n2 state, and there will be no particle in the n1 state. So n becomes 0 minus n, or this becomes minus n, which is less than equal to 0. So at temperature 0 and entropy 0, so this is called E equal to n epsilon becomes minus n epsilon. Clear? So as the temperature, when we will increase the temperature, the energy supplied to the system and the particle, they will jump from the lower state to the higher state. When we will supply the additional amount of energy, the particle will shift from this energy state to this higher state. So the upper energy state grows at t greater than 0 till we have n equal to 0. N equal to 0 means in the first state the number of particle is half, and the n2 state the number of particle is half. That is, here suppose the particle is n by 2, and here also the particle is n by 2. At this condition, so the entropy, so till we have n is equal to 0 and the entropy is nk log 2. So this is called the state of maximum disorderliness, or t tends to plus infinity. Again, if we supply more energy to the system, then the upper energy level becomes more populated than the lower energy level. So here you can see that this is your energy level minus epsilon, this is your plus epsilon. So at this case, when we will supply more amount of energy, then what will happen? So in the particle, that is the n1 number of particle, it is suppose n2 number of particle in minus epsilon state. So the now in the positive epsilon state, the number of particles becomes more as compared to this. So in that case, small n, that will be greater or equal to 0. So it means that we will decrease in entropy, or the more ordered state. So this is called T is less than 0 or the negative temperature. So you can now conclude that this negative temperature, it corresponds to the higher energy than the positive temperature. So it means that first of all what we have did. So first of all, at T equal to 0, all the particles in the N2 state. In the next case, if we will supply the some amount of energy, so in that case when T is greater than 0, so the number of particles becomes here the half number of particles and here the half number of particles, so that N is equal to 0, small n is equal to 0. And in the next case, when we will further increase the energy or supply, the amount of energy supplied to the system is increased, in that case the number of particles in the higher state will becomes greater than the lower state. So in that case we can say that the negative temperature is achieved. So if the negative temperature and the positive temperature systems are brought in thermal contact, then the energy will always flows from minus state, that is the negative temperature state, to the positive temperature state. So this negative temperature state is actually more hotter than the positive temperature state. So for a system to have negative temperature, some conditions must be satisfied, that is, it must be in equilibrium, it must have a finite upper limit to the energy, and it must have the negative temperature state isolated from the positive temperature state. So from this graph, what we have concluded that at T equal to 0, so here we have plotted the curve between E by epsilon n versus S by nk. So at T equal to 0 state, the probability of occupancy P1, it will be 1. It means that all the atoms will be in the energy state minus epsilon. That means in the lower energy state here. So the internal energy of the system, it will be 0. So this is the state of minimum disorder and it corresponds to S equal to 0 state. This means here. So again, as T increases, when the temperature increases, the occupancy in the higher energy level, it begins to rise. That means that as T tends to infinity, in that case, the probability of occupancy P1 and P2, they will be 1 half. That means the both levels are equally occupied. It means that when the temperature increases, that is positive infinity, so here the number of particles become half, and in the N1 state it becomes half. So the internal energy will be N epsilon by 2. So this corresponds to the state of, this is called the maximum disorderness. So the maximum entropy, so in the region, so in this region, so the energy lies between 0 to N epsilon by 2. 0 to N epsilon by 2. So the derivative of S with respect to E, this will be positive. So we can define this as positive temperature state. Clear? If more atoms tends to occupy in the N1 state, that is the higher energy state, it means that N1 is greater than N2. So in that case, the population inversion is achieved. So in that case, when N1 is equal to N, it means that all the particles are in this state. So N1 equal to N. So in that case, the internal energy will be N into epsilon. So it means that this is the minimum disorderness and the zero entropy, that is called the T is negative. So the energy here, it lies between N epsilon by 2 and N epsilon. So the slope of this energy curve is negative and this is called the negative temperature. So the paradoxical result is that a system at a negative temperature, it is actually the hotter than the infinite absolute temperature. Are you getting my point? The negative temperature means the negative temperature is hotter than the infinitely absolute temperature. So the negative temperature is not below the absolute zero, but it is just above the infinite absolute temperature. So that's why we have called that the negative, when they are brought in thermal contact with each other, so the temperature, the energy will flows from this T negative state to the positive temperature state, this T minus state to the T plus state. So this is all for today. Thank you.